You added a transactional. Your code looks fine, no errors, no warning, but somehow the database commits while it should roll back. The problem is not your SQL, it's not your database, it's how Spring actually works with transactions. And the moment you see how they fail, you will basically understand how the project silently fail in real environment. I have prepared this project, and basically we have two entities. One is called isolation counter, which is going to be used in testing the isolation levels. And we have journal entries, which is basically going to be for almost the other test cases that we have. Those are the two entries. We have also helper method in our journal entry repository, which is basically going to be helpful in assertion. I won't really walk you through each one just by me reading it loud. Why? Because I don't really feel like this is a good way to learn. So what I'm going to do is I'm going to be walking you through one by one, but through unit tests. Unit tests cover almost everything we have here. So we have all the services that we have. If we're talking about same class, cross class, or basically different classes. But just before I'm gonna be jumping into the other services, I want to speak about what transactional really do. Transactional basically, it has some kind of scope that wants to be executed. This scope is SQL. You begin your transaction, you write your SQL statements, and then you commit the SQL statements. In case some kind of any failure case that happen, you might want to roll back. So if a rollback happened within the transaction doesn't get saved, or basically doesn't get committed, and as a result the database will not be affected and will not be impacted with your changes due to that transaction that was rolled back. That's basically the idea of transaction. So what happens when we're in a Spring Boot project and we use the add transactional annotation? What happens here? It uses something called AOP, aspect oriented programming. The idea of aspect-oriented programming is pretty straightforward. We're using a proxy. What is a proxy? A proxy is a way of hiding complexity. It's abstraction to you. Basically, when you're annotating some method with a transaction, Spring behind the scenes creates this proxy for you, starting a transaction and doing your SQL statement, which is basically your method that you annotated with, and at the end it commits. And in case of failure, it rollbacks. That's basically the idea of transaction and how Spring works with it. So let's get back to the test that we have, and we're gonna be discussing each one of our services. So I'm gonna be telling you what services we're gonna be testing out. We're trying if we're calling a transaction through same class or different classes, or we're talking about different kind of propagation. We're talking about if you have nested transactions where one is big and the other is inside this big one. So this is also gonna be tested here. If we're talking about no rollback for some kind of transaction, also in multi-threading and concurrency. Also, we're gonna be talking about read-only transaction and how it impacts in Spring. We're also gonna be talking about the isolation levels, and we're gonna test it out as well. And there is some kind of scenario related to the unexpected rollback that's happened if you have a nested transaction. We're also gonna cover it out. Those are just two OTORs, which are basically a Spring Boot context that provided by us. So now before each, we're gonna be clean up everything in our database. And by cleaning up everything in our database, we're removing all the tables that we have before each unit test. Now let's start with our first unit test, which is basically same class self-invocation. We have a class. This class has an add transaction, and we want a method to call the transactional method. This happens within the same class. By the way, in the transaction method, we're saving an entity. So that's basically our work, and then we're throwing an exception. We're saving an entity, and then we're throwing an exception. And as a result of this, what happens is we should roll back, but what happens since it is within the same class, we're saving it normally, like we're getting the count of this scenario to be equal to 1, which isn't really what's expected, but this happened due to the fact it is within the same class. This is also the way of working within the same class because it doesn't really create a proxy for you. But what happens if you call the add transaction directly, not through the same class? What happens if you are in another class and you call this transaction method directly, such as this case? What happens is you're throwing an exception at this time, and it shouldn't really roll back because you're calling it from a different class. This class that we're calling it is this integration test, and as a result of this, we find this count to be 0. This means it didn't really get saved, and basically the proxy happened, and this is why it worked as expected. This is for the same class. What happens if we have different classes and those two different classes call each other? So we have this class that calls this worker is basically a wrapper for our transactional methods. We all do the same. We have journal entries, we save a new entity, and then we're throwing some kind of an error. So what happens here, since it is in a different class, it works as expected. It's gonna be try to save it, and then it's gonna throw an exception, and as a result, it's gonna be expecting it to be not saved, eventually to be 0. Also, if we have a different class, but it check the exception. So what happens here, we have this worker, it's gonna be check exception. This basically a transaction method that throw business check the exception. This is a check the exception, that means it gets triggered in compile time, not runtime. So what happens here? Here we just annotated with add transactional, and when we're trying to test this kind of behavior, we will find out that it is actually saved, even though it's through an exception and we're calling it from a different class. Like, why did it really work? Because in a checked exception, a transaction doesn't really behave as expected. Why? Because it is checked, it is at compile time. So basically, if you are expecting it to happen, then you need to tell add transaction annotation, hey, be careful to roll back for this checked exception. And we're not doing this in this behavior. In this behavior, we're not annotating with anything. It just add transaction. And this is a special behavior when you're working with a checked exception. And this is why in add transaction, you will find it saved, even though we're throwing an exception here. So how can we resolve this? We can resolve this by making it roll back for this checked exception. When we add this part, this means in the next unit test that we have, it's not gonna be saved, just due to the fact that we only included this portion, which is rollback for this specific checked exception. And as a result of this, we're not gonna be saving this new entity, and as a result, it works as expected. This is also a special case behavior for checked exception. So what happens now when you're creating a transaction? By default, you're creating it with propagation of required. That's a normal default value of transaction annotation. So what happens here, if you're gonna be trying out, like I'm gonna be showing you the default value here. This is the default value required for propagation. You don't really need to add it explicitly. It's gonna be added by default. So here we have an outer transactional, which is of type required. And what happens, you are saving an entity, and then we have another service. This service is saved in require new. You will find a new propagation called require new, where we save a new entity. So what happens here is we opened up a big transaction. This big transaction, inside it, we're requiring a new transaction to be opened for the inner method that we want, which is basically save in require new. And this is like the meaning of propagation requires new. We want a new transaction to be open. And as a result of this, outer transaction is rolled back, but inner transaction is committed. Why is this case? Because when we're creating a new transaction, this new transaction is closed before the end of the outer transaction. So the inner transaction is complete, is done, because it finished executing, it committed its work. This means the inner scenario is going to be 1, but the outer one is not completed because it's through an exception in this part. For the next unit test, it's going to be for the nested case, where we have a nested transactions. What happens here? In this nested rollback, this big method. So this is a nested transaction service. We have 2 transaction templates here. One is for the outer template, one for the nested. And I'm going to be using a custom transactional manager here, I'm gonna show you the configuration just right now. The main difference here, we're allowing a nested transaction because it is not allowed by default. So we want to test this behavior. This is why we're creating this custom transaction manager. So what happens here, we're creating a new transaction. Execute without result creates a transaction for us. So within this transaction, what happens is I want to update a specific scenario, which is basically outer before. We're gonna be inserting into our journal entries an outer before. So this is what's gonna be provided before, and then we're gonna be trying to create a new transaction. This new transaction is responsible for inserting a new record in our scenarios, which is gonna be the second argument that we have. And then we're gonna be throwing an exception. So theoretically speaking, this one should roll back. Why? Because we have an exception thrown. But since it is allowed to set nested transaction allowed here, then what happens here, we're expected to be stop this inner middle transaction, but the outer transaction to be working normally fine without any issues. So what happens after this inner insertion here, the middle nested transaction? We're gonna be trying to insert another scenario which is outer after. So expected here, the first one, which is outer before, is to be inserted, but the inner one, which is the middle, is not inserted. And for the outer after, which is basically after the throwing exception, we're also expecting it to be 1. This means it's going to be inserted successfully. This is for the nested using the custom transaction manager that we have. I'm going to be also talking about the no rollback for. The no rollback for, when we have some kind of custom exception, this custom exception, we can specify it to be, hey, I don't want rollback for this exception. So we're saving here an object, an entity, but we're throwing an illegal exception. So if we don't really have this value, then it should have rolled back. But due to the fact we have no rollback for this illegal state exception, which is what we throw here, then it is gonna be saved normally without rolling back. So also I want to introduce that if we're talking about private transactional method, that means we're calling a transactional method on private modifier. That means that it's gonna be called across the same class, which isn't really the right way. And due to the fact that it is in the same class, this means it's not gonna be working as a proxy, and as a result of that, it will be completely ignored and saved successfully, completely normal. We're gonna be talking about the async does not share the outer transaction context. This is something you might miss if you're not knowing what you're doing. So what happens here? Outer transaction inserts but has not committed yet. It made some insertion, it saved an object, but it didn't really commit the transaction. And we have an async method that run on different thread or different transaction. You wouldn't be able to see the uncommitted data. So in the outer transaction, we have saved, we have inserted, but we hadn't really commit. And we have another thread that run on different transaction, and that means we cannot see the uncommitted data. So basically, it is not aware that it is within the outer transaction. And let's view what's happening here. We have this at transactional. We're saving an object. Currently, we have saved it, but hadn't commit the transaction. And then we have async counter service. This is responsible for what? We have a completable future in order to count by scenario. So we want to get the count. So expected here, even so that we have saved the scenario here, it should have been saved. But since we're calling here using requires new, a different transaction, and we're calling it async as well, this means it is not aware with the transaction scope of the previous transaction, which is basically from this one. This means it's gonna be returning of count 0. This returns completable future of 0. And when we're joining, we should be returning 0 until the whole outer transaction is completed. Then eventually it's gonna be 1 and completely saved due to the fact that the outer transaction is now completed. And this is what happens. If we're gonna be asserting on this, it's gonna be 0, but after the completion of the transaction, we're gonna be asserting it's gonna be 1. This is also a special case that you might want to handle. I'm gonna also talking about reading only is just a hint. It doesn't really mean anything. If you added a read only here, it doesn't really mean anything at all. It is just some kind of a hint. We're here just returning it as a boolean value, but basically we're just inserting. Even though it's read only, it's gonna be saved completely normal and it will have no issues at all. We're gonna be expecting it to be 1. And I'm gonna be also talking about unexpected rollback exception. This is a rollback exception happened when inner transactional through an exception, and both transactions are the same. We don't really have different transaction here. We have one transaction and the transaction gets propagated. I'm gonna show you how it gets propagated here. Here we have a transaction, which is by default here, it's gonna be required. And what happens here, we're saving an entity and then we're gonna be trying to save something else within another transaction. This is the same transaction as before. It did not really create a new transaction. It is the same transaction as before. And we're gonna be saving a new scenario and throwing an exception. Due to the fact that we are throwing an exception and we're using the same transaction as before, like we're not creating a new transaction, this is one, then it should be throwing an exception here, and as a result of this, it should have committed the transaction, but it didn't really do this. Why? Because since it's one transaction and we have an inner transaction that failed, but both saves that happen within this one transaction are not completed. This is why a rollback happened, and due to this we have unexpected rollback exception, and outer scenario and inner scenario are not saved, therefore they are both 0. So our last unit test that covers isolation level, which is kind of big topic here, but I'm gonna be showing you a sneak peek regarding the isolation level. I'm also gonna be talking about this diagram because it feels a bit easier to understand. We have our main thread and we have a thread A. Our main thread is our entry point here. We want to read a task, which is basically just, hey, transaction method, and we want to begin a transaction. We're gonna read at first time. It exists in our database as 100, so we're gonna be reading it as 100. So this is the first read. It's done. We read it as 100. Now we're creating a new transaction using require new. This new transaction, what happens here, we're gonna be updating it to be 200 within the new transaction in a different thread. This different thread updates the record to be 200. That's the update behavior in a different transactional. And now the transaction is committed because it is a different transaction. And when it is done and you're gonna be trying to read one more time for the previous transaction, you would find out it is gonna be 200 and not 100. Why? Because you're using a read committed isolation level. You're only reading the committed values or committed transactions. This is what happens here. So I'm gonna be showing you in the code right now. Same transaction in thread A reads different value. Why? Because read committed allow non-repeatable reads. So basically you only read what is committed, you don't really read uncommitted values. So let's get started. We have now I'm gonna be showing you initialize here. It's basically we're saving in our database 100, which is basically the default values that happen. So basically we're just starting out with 100 in our database for this specific ID. And we have a first read done and update done, which is basically countdown latch. Countdown latch, by the way, is just do something until it reaches to 0. And when it reaches 0, then great. That's basically you're latched already. So we're gonna be starting with 1. And we're creating an executor service. And the first thing that we're gonna be doing is read twice, read committed. That's basic. So we're expecting to read first time, and then we're gonna be reading a second time at the end. And in between, we're gonna be creating a new transaction to update the old data, which is 100, to be 200. So first read is gonna be 100, and then we create a new transaction, update it to 200, eventually rereading it again, and it would be 200 due to the fact that it is now committed. Let's view this. So now we're gonna be read the first amount, and then we're gonna be decrementing the first read countdown latch, which is the first read. So now we have reached to a 0 in the first read, and then we're gonna be awaiting the latch for the update done. So the latching for the update done doesn't really happen here. It happens in this part. Isolation demo service update amount in new transaction. So we're creating a new transaction here, and we're setting the count to be the net amount which we provided, which in our case is 200. And then we're decrementing, it's the update done. And when we're decrementing, this means the await latch is now completed, and we're reading it for the second time. And we're eventually creating our DTO for the first and second. So first is 100, second is 200. And now when we get the result here, after waiting for the 5 second as timeout, the first read is going to be 100, the second read is going to be 200. And this is happening due to the fact that we have a read new, which is basically a new transaction, and we're working with a read commit isolation level. And if you didn't really notice where did the isolation level happen, this is the isolation level is provided in this area. That's basically how we're going to be testing this kind of stuff. And I'm going to also link this repo. You can have this kind of add transactional guide in your pocket. I'm going to be posting it on YouTube, and I'm going to be adding the GitHub repo in the description section so you can view it here. And when I rerun this application or unit test, all of them should be running successfully. Yes, now 13 test passes, and that's basically how transaction works in Spring. Hopefully you now have a better understanding of how Spring works with add transaction, concurrency, you name it. Like I believe I have covered almost, I'm not gonna say all because I believe there are still more ideas, but the way of thinking when you're working with add transaction. So if you like this content, comment that down, and you might like this video or this video, some video in one of those area, and see you next time. Bye bye.